Look at a steam locomotive in motion, and it's impossible to look away from its wheels. There is something completely hypnotic about those massive, heavy steel rods plunging back and forth, driving the train forward. But have you ever stopped to wonder, what exactly are they doing? Why couldn't they just build an engine that spins the wheels directly from the inside, like a modern car? Those giant metal arms aren't just there for visual drama. They are solving a massive physics problem that threatened to stop the railway revolution before it even began. Welcome to Simple Things Surprising Histories. Today, we are looking at the simple brilliance of steam train rods. To understand these giant rods, we have to understand how steam power actually works. Inside a modern car, tiny explosions push small pistons up and down, turning a hidden crankshaft that eventually spins your wheels. But a steam train works on external combustion. It boils water to create high-pressure steam, which is fired into a giant cylinder at the front of the train. That steam pushes a heavy piston forward and backward. That's it, just a straight back and forth motion. But a train doesn't slide on skis, it rolls on wheels. So engineers had to figure out a way to turn straight line motion into circular motion. Enter the first massive rod you see on the side of a train, the connecting rod. This thick beam connects the sliding piston directly to the center of the driving wheel. As the piston pushes back and forth, it acts just like your leg pedaling a bicycle, turning that straight push into a powerful rotation. So the piston pushes the connecting rod, and the connecting rod turns the wheel. Problem solved, right? Not quite. If you look closely at our train, there is a second set of rods connecting all the big wheels together. These are coupling rods. Imagine trying to move a million-pound train using only two powered wheels. A train runs on smooth steel wheels, setting on smooth steel tracks. That means there is very little friction. If you send all that massive steam power to just two pairs of wheels, they will violently spin in place without gripping the track. It's like flooring the gas pedal on a sheet of ice. The coupling rods solve this. By mechanically linking 3, 4, or even 5 pairs of massive wheels together, the engine distributes its tremendous power. If one wheel starts to slip, the others grip. They share the burden, giving the massive iron beast the traction it needs to pull thousands of tons. But there is a hidden genius to these rods that you can only see if you look at both sides of the train at once. Think about riding a bicycle. If both your pedals are perfectly vertical, straight up and down, you have no leverage. You get stuck. In engineering, this is called dead center. To prevent a multi-ton train from getting stuck at a dead center stop, engineers used a brilliant trick called quartering. The rods and pins on the left side of the train are permanently offset by exactly 90 degrees, or 1/4 of a turn, from the rods on the right side. Because of this, no matter where the wheels stop, one side of the train will always have maximum leverage to start pushing again. Those heavy, plunging rods are much more than a nostalgic symbol of the industrial age. They are the mechanical veins of the locomotive, turning raw, explosive steam pressure into the steady, gripping rotation that built the modern world. The next time you see a steam train, you'll know exactly the magic happening on the outside. If you enjoyed this journey into the past, make sure to hit that like button, share this with a fellow history lover, and subscribe to Simple Things Surprising Histories for more hidden stories behind the everyday world. Thanks for watching.